Hey there. So we're going to go over your answers or questions here for the station activities that we did in class here. So starting at station number 1. So station 1 was a tree ring one. And it asks here, number 1, which year was the tree cut down? So that would have to be the year that is the, oldest year or youngest year, I guess I should say. It kind of depends on how you look at it. 1883, because the tree grows from the inside out. So whatever year we figure out is in the middle, that's the year that it was cut down. So number 1 should be 1883. And then number 2 asks, what were the 3 most dry years in the tree's life? So dry years are indicated by rings that are very close together. And so since I've numbered these here, we can see as I zoom in a little bit that my 3 driest years should be right around here. So from between 1877 to 1880. That's what I would put there. So 1877 to 1880. And then what year was the most wet year? So we're looking for the area with the thickest growth. So it's kind of a toss-up between 76 and 77 and 80 and 81. I guess I would go with, I think this one's just slightly bit bigger. So between 76 and 77. Now, it asks for 1 year, and I realize that's 2, but depending on how you're looking at it, you can kind of count them different ways. But between 76 and 77 should be fine. Like I said, it's probably the summer of one of those 2, but for our purposes, doing a hyphen like that is fine. All right. Station number 2 is a Vostok or a core, an ice core from Vostok, which is a location in Antarctica. And this is recorded CO2 levels. So again, you're always going to want to make sure that you're looking at the, the title of the graph. What is it asking you for, as well as your y-axis, which is CO2 concentration, and then ppmv. ppm stands for parts per million. And when we look at this graph here, it says on the x-axis, age of entrapped air, and then it says KYR, and I tried to make sure that most of you saw that. KYR stands for kilo, which is, sorry, these things keep popping up, kilo year. So basically you have to add 100,000 or like 1,000 behind each of these numbers. So it's 100,000, 200,000, 300,000, 400,000, okay? So when we answer these questions, we want to make sure that we, include those values. Which of the 5 pieces of evidence for climate change is shown in this graph? So this, again, is an ice core. So you can just write ice core there. And ice cores are good because they can go back quite a ways, not millions of years, but definitely thousands and hundreds of thousands of years. Number 2 says, which year experienced the highest level of CO2 in the atmosphere? So I'm looking for a year, or how many millions of years, or how many thousands of years ago. So what you need to do is find the highest point, which is going to be right here. And then you need to go straight down and figure out where that is. So you can see I get to about right there. And I have some other things marked on here. These weren't marked on your sheet when you looked at them, but most of you probably traced a line down here, noticing that it's about halfway between 300 and 350, maybe a little bit closer to 300. So I would say around 320 to 320,000 years ago. That's, I guess, when I would put for number 2. All All right. So again, the air is 320,000 years old. So when we look at our graph and whatnot, like this would be the newest data. Not usually we're looking at this side, but it's actually this side would be like the newest set of data, like from the closer years to us. So again, about 320 or so, 325,000. If you put 325,000, that's totally fine. What is the lowest CO2 concentration during the last 400,000 years? So the lowest CO2 concentration, you have to look at this graph over, or the numbers over here, and you're looking for the lowest value, which is just right here. Okay. So that number occurred just about maybe 10,000 years ago or so. And it's right in between about 170 and 190. So it's right around 180. And again, value or units would be ppm. 180 parts per million. So what pattern or patterns do you notice on the graph? So there's really two things that I want you to notice on here. Okay. One is that, again, we're going from like this to this way. So I want to kind of talk about it in terms of time going from here to here. So what happens is the CO2 level drops slowly. All right. And then it increases rapidly, and then it drops slowly, then increases rapidly, drops slowly, increases rapidly. So you should have something like that written for number 4. And then the other thing that I want you to notice is that this is actually kind of on a cycle. We can see the same pattern kind of happening, dropping, increasing, dropping, increasing. So if you look at the height of your largest ones here, so again, we already said that one's about 325 years ago. This one right here is about 225,000 years ago. This one here is about 125,000 years ago. And this one we're still at that point right now. So it happens about every 100, or so thousand years. That's another thing to note here. So every 100,000 years. As we move and get more into this unit, we'll kind of see that cycle kind of repeat and talk a little bit more about why. All right, station 3 here is another tree ring one. So this question says the middle number is 1620. So that means each year going out here was the year before. So 1619, 1618, 17, all right, all the way to 1610. So again, 1620 would have been the year that it was cut down, and 1610 would have been the first year. So it says, compare and contrast the moisture conditions the tree experienced early in its life and later in its life. So with this question, honestly, it gets a lot of moisture at the later end of its life and at the beginning end of its in terms of moisture levels. So if you want to say it gets a lot of moisture at the beginning part of its life, right here, that's why we have bigger, thicker rings there. And then at the end, those are kind of thicker rings too. It's sort of in the middle that it ends up hitting sort of a drier spell. So that's, I guess, what I would mention. I know it only asks about early and later in its life, but it actually gets pretty decent, moisture early and late, but it kind of gets less in the middle. Says, which year is the most dry year? So you're looking for the thinnest ring or the smallest ring. I guess I would go with, this one right here, all right, which is between 1913 and 1914. Or sorry, 1613 to 1614. And then what year was the tree cut down? That would be the year in the middle. Or sorry, how old was the tree when it was cut down? 10 years. Okay. 10 years old should be. All right, station 4. This one was a little bit of work here you had to do, and so I want to make sure that you were able to kind of see everything that I wanted you to see here. Hopefully, you're able to see the years. If not, I kind of made some some cheater numbers here so we can look at these. So with station 4, number 1 says, during which years was the temperature lower than normal? Well, what's normal? So here we have annual mean, which is in blue, and the 5-year mean, which is in red. Now, I prefer to look at the 5-year value because there's less up and down with that and more of a, kind of a standard sort of motion. So I prefer to look at the red value, but the blue value is the same, except essentially it just keeps going up and down. Now, over here on the side, we have temperature. And we have 0 degrees. That's going to be our normal. All right. So 0 degrees is going to be the normal. And if we're negative, it means we're below normal. And if we're positive, it means that we're above normal. So it's asking, number 1, which years was the temperature lower than normal? So you're looking at like what group of years was the temperature lower than normal? Now, these are historical records taken from humans from 1880 to 2009 here, which I guess is considered present. So if we look at this graph here, we want to focus on that 0 mark right here in the middle. Actually, I'm going to draw that in a different. Okay, so I put it in black there so you can see it a little bit easier and doesn't get confused with the red line. So I'm looking for what years is the temperature lower than normal. So I have to be able to figure out which years those are, and then is there more than one like set of years? There actually is. There's actually 4, but I'm really going to show you just 3 of them, and I want you to have these 3 down there for sure. Okay, like I said, there is a 4th one, but it's so very small that I don't know that it's worth mentioning. All right, so the years that I'm looking at here are the years that it's below the graph. So I have from 1880 all the way, these are all below, and I'm looking at the red line, okay? I'm focusing on the red line, not the blue line, just focusing on the red line. And when I do that, I notice right here, okay, is where it goes up above 0, and then it stays there for a couple years, comes back down. So these years are below the line, this year's above the line, and then these years are below the line as well. Like I said, I do have a couple more in here, but I'm not going to focus on those. So my years that I want to record, okay, are all of these. Okay, so these kind of 3 segments that I've sort of colored in here. So the first one is from 1880 to this right here. So I have 32 and 38. So I would say this is about maybe 1936. So that's what I'm going to go ahead and list down for number 1. So it'll be 1880 to 1936. Okay, that's my first set. So that takes care of everything from here to here. So make sure you have these years right there, 1880 to 1936. All right, then this year it's above normal, and then it comes below normal again. So if I look here, this is 1945, so that would maybe be like 1946 to about 19, maybe 56. Okay, so that's the second set of values here that are below the 0 mark. And then my next one is this little one right here. So if this is 1963, that's probably about 1961. And then this is about maybe 1967. Okay, so 1961 to 67. right. So again, those are the 3 years that I would like to see you have on there. So if you had something different than that, or you just had a single year, I'll ask you to change them. Number 2 says, why would this be a good graph to include in a report about climate change? Um, so the year 1880 is important because that's when humans, first started being able to record temperatures. So it's important here because we want to be, it shows temperatures as change as a result of, at least when humans have been able to record their differences. Another big thing that also happens around this 1880 year is the Industrial Revolution, which is when we start burning fossil fuels and specifically coal into the atmosphere. And so those are when some of those anomalies kind of start to take place, is the years following that. All right. So that's always kind of interesting to include. So again, it's just represents, how humans have been able to, since humans have been able to track how the temperature has changed. However, how might this be a poor graph? Number 3, it really does only go back, 150 years, and our world is much older than that. So that's, I guess, what I would put down for number 3. And it only goes up to 2009, which, that's about 13 years ago or so. So we're past that now. Number 4, summarize this graph in 1 or 2 sentences. I'll kind of leave that up to you. All right. You should be able to do that. Station 5 is looking at these pictures, comparing, contrasting what changes can be seen, summarizing, listing 2 skeptical questions a skeptic might have about these pictures. I'm going to leave those up to you. I think you can do those just fine. Station 6, this was another tree one. So it says, during what year was this tree cut down? So 1982 is listed as the tree's year right here. So this would have been right around the year that it was planted. All right. And so every year you have to add a year going up if I'm going up this way. So 83, 84. And again, this time it was the growth years that were labeled. So I'm putting my numbers in between here. So I have 83, 84, 85, 86, 88, 89, 90, 91, 92. And then I just listed this dot here as 93 since we're counting it kind of separately. So during what year is this tree cut down? If you say 92, 93, that's fine. Either one's good. During which years did the tree experience drought conditions? So I guess I would say between 89 and 91. 89 and 91, those years are drought condition years, it seems like. And number 3, there actually is a mistake on this question. It should be the 1984 year. So it's asking basically, where did this black part here come from? It says it's damage. All right. So as far as damage goes, again, this would have been done likely when it was growing here back in like 1984, 80, so we have, about 84. So again, it looks like it was caused during most of the tree's growth. Maybe at that, time in the inside, maybe there was a parasite, maybe there was a fungus or a bug or something that was eating away at it, and it somehow was able to survive that. We also have like trees that will start to try to grow branches. That's what causes knots in wood, is those are actually branches that come from it. So that could have been the cause of it too. 7 here. So 7 was looking at Arctic sea ice and the extent of it, and specifically comparing a couple of them. We looked at this before. During which months does the Arctic sea ice cover the most square kilometers? So I'm looking at this first, kind of the blue marks that I've made here. So we have, from February to April, about is when the most of the sea ice is there. If you want to say January to May, that's okay too. It's just something where along the course of these months here is fine. And then number 2, which months does the Arctic sea ice cover the smallest area? Again, I kind of have between August and November, but if you want to extend that out a little bit, July to November, July to December, that's up to you. Just make sure, like I said, it's a range around that, the smallest and highest point. Number three, how's the extent of sea ice changed from 1979, which is the blue line, to 2012, which is the green dash line? So 1979, I believe, was like the highest it's been in a while. In 2012 is the lowest that it had been in a while. Again, we've actually changed since then. We've actually gotten lower, but this is older data. So how has it changed? There was less that was made, right? The extent of the sea ice, there was less that was made during the winter or during these months here. And then there was a big drop also in the summer months as far as how far out or how much ice was made in the summer months. So there was less ice made between 1979 and 2012. And then number four, explain why Arctic sea ice seems to grow and shrink during a single year. And I explained this in class to you as well. So during the quote unquote winter months in the northern hemisphere, that's where Arctic is found, North Pole, the sea ice grows because our Earth is tilted away from the sun during the winter. And as we tilt back towards the sun in the summer, it starts to warm up and we get more heat and radiation tilted in the northern hemisphere, and we see that represented here. Now, we actually have the most amount of daylight on June 21st, but we don't have the least amount of sunlight or the least amount of sea ice that day. The reason for that is it takes our Earth a while to actually warm up. So, we're sort of building up in that sunlight as throughout the year. And then, usually for us, like July and August, those are the hottest months for us, right? Not necessarily June. June is usually warm, but not the warmest month. And the same thing with December 21st is the coldest or the shortest day of the year, least amount of sunlight. We're tilted farthest away from the sun. However, usually it's colder for us in January and February than it is December. All right, I'm going to stop there for today because I think you probably have plenty of information there. And Station 8 is a little bit longer, so I'll discuss that with you guys in class.